Here's an integral that goes up to infinity. This is called improper integrals. That was section 8.8. But the nice thing about improper integrals is that you don't really need to do anything different. You just kind of do the integral as usual, and then when you like plug in the infinity, if it is something that goes to zero, then you're good, and if it's something that doesn't go to zero, then it's divergent. So that's a possibility, but definitely wouldn't want to just guess that, I think. So let's see what we can do here. What kind of anti-differentiation technique will work for us here? Well, I definitely have a what's inside thing going on here, so maybe it's u substitution. So if I let u equal the what's inside, then du would be equal to 3x squared dx, and I've got the x squared, so that's good. So if I put a 3 here, then I just need 1/3 on the outside to balance that out. So what does my new integral look like? So I need new u numbers. Plugging 1 in here, 3. Plugging infinity in here, I get just another version of infinity. And here, the 3x squared dx, that just turns into du. And then I've got u squared on the bottom. You could write 1 over u squared. I'm going to write u to the -2 because that's more calculus friendly. All right. What's the antiderivative of u to the -2? So I bump the exponent up by 1 to -1, and then I divide by that new exponent. So that's divided by -1. Dividing by -1 is like multiplying the whole thing by a negative sign. And I'm going to put that on the outside. I feel like I'm a little bit less likely to make a sign mistake if I just bring that to the outside. All right, so I've got -1/3 times u to the -1, that's 1 over u, so that's 1 over infinity minus 1 over 3. And 1 over infinity, that does go to 0, so this is an improper integral. It does exist. So -1/3 times -1/3 is positive 1/9. That's B. For what values of x does this graph have a point of inflection? Point of inflection means the second derivative changes sign. All right, so let's see if we can find the second derivative. So let's see, 15x to the 4th plus 40x cubed. Second derivative would be 60x cubed plus 120x squared. So we want to know, where does this change sign? Well, setting it equal to 0 is a good idea. And factoring, there's a 60x squared in common. Maybe x plus 2. You could make a sign chart, 0 and, oh dang it, did that again. And -2 is crowded over here. But kind of like, oh, what number was it? Some earlier number. This is x squared, so we're not going to get a sign, because this is being raised to an even power, we're not going to get a sign change at 0. We are going to get a sign change here. You can go ahead and run through here and see what happens. If you plug in something like -3, you're going to get a negative, because this is always positive, and then this will be -1. If you plug in something like here, like -1, this is positive, well, that's always positive. And then if you plug in something bigger than 0, then everything's still positive, so we don't get a sign change there. So the definition is changes sign. That only happens at -2. If you're wondering where this 8/3 came from, that's for somebody who was checking out the first derivative, where that's equal to 0. Number 20. So f prime of x equals this, so this is a derivative, and g of x equals f of that. What's g prime of 2? Well, let's just take the derivative of g. So g prime of x is equal to f prime of that. But since this is not just an x inside, I'm going to do the chain rule times the derivative of what's inside is 2x. So let's see if we can do this. So that means g prime of 2 is equal to f prime of, plugging 2 in here, that's equal to 2 squared minus 1 is 3, times 2 times 2 is 4. So we just need to figure out what's f prime of 3. How would we do that? Well, let me give us what f prime is. So f prime of 3 is, let's see, 3 minus 2 is 1, cubed is 1, times 3 squared is 9, minus 4 is 5, over 16. So that's 5 over 16 times 4, which is 5/4. And there's the tragic answer of 5/16 if you forgot the chain rule here. But got to remember the chain rule. All right, number 21. Table above gives selected values for a differentiable function f and its first derivative. Using a left Riemann sum with 3 subintervals of equal length, 1, 2, 3, which of the following is an approximation of the length of the graph of f? Okay, so the length of a curve. We can't just go charging in here finding a Riemann sum. We need to actually think about length of a curve. That's what it's asking us to find. And we're going to somehow use a Riemann sum to help us out there. So length of curve is equal to the integral from wherever to wherever, in this case it's 1 to 7, square root of 1 plus dy dx. I'm going to call it f prime of x here because that's what they called it. All right. So where do we go from here? Well, I'm just going to do all I have is the data in the table here. So I need to use that data to approximate this integral. So the thing that I need to do, each one of these intervals is 2 wide, but the heights of this integral are this expression. So the first rectangle, well, all the rectangles are 2 wide, right? And then when I plug in here, since I'm doing a, left Riemann sum, a left Riemann sum, then the value of f prime right there at 1, this is my left endpoint, is 2. That's 1 plus 2 squared. That's the square root of 5. That's the value of this function here. And then next subinterval is 2 wide. Left endpoint is this, so I'm going to use this 1 here. That's my f prime of x value. So 1 plus 1 squared is 2. Next one is 2 wide again. Use this. That's the square root of 1 plus 0. Square root of 1 is 1. And then the last one is 2 wide. And then I'm going to plug in negative 1 here. Negative 1 squared is 1. So that gives me the square root of 2. So that's the left Riemann sum approximation for this integral. So let's see. I've got 2 square roots of 5, 4 square roots of 2, plus 2. So that looks like this. Answer choice E. And looking at my answer key here, and they have that the correct answer is this. So let me just try to figure out what is going on here and why I'm not getting that. So why am I getting... Oh, there's only 3 subintervals. I went all the way to this one. That's a 4th one. Oh my goodness. Sorry about that. So that means there's only 2. It's a left Riemann sum, so left, 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 done, right? And I went all the way to there and included a right rectangle, which is the major faux pas. So that's not the right answer. This is. Funny that they included that for somebody who made that same silly mistake that I just did. All right. What's the interval of convergence for this power series? Well, it's an x minus 3 here. So right off the bat, I know that this is a series that's centered at 3. Centered at 3. So are there any answer choices I could eliminate? No, these are all centered at 3. So I guess I have to do the work. Oh well. So let's see, interval of convergence, that's a ratio test kind of thing. So I need to find the limit as n approaches infinity. The n plus 1 term divided by the n term. You cannot get these backwards. It doesn't work. It's n plus 1 term divided by the n term. All right, now we got to simplify this without messing that up. So let's see. On the bottom here, I've got n, x minus 3 times itself n times, and I've got one extra one here. So all of those cancel out with all of these except for that last one. So I've got an x minus 3. And here, likewise, got 2 to the n here, and 2 to the n plus 1. I've got an extra 2 on the bottom. All the other 2's cancel out. And then I've got n over n plus 1. But as n approaches infinity, n over n plus 1, that's like a gazillion and a gazillion plus 1. That approaches 1, same power, top and bottom, all that stuff, easy limit. So this whole limit just approaches x minus 3 over 2. And to find the interval of convergence, that thing needs to be between -1 and 1. Algebra. Add 3. Okay, so it's not those. Now, I need to check some endpoints here to see which one of these it is. So let's check 1 and see what happens. So I'm just going to go back to this here. So if I plug 1 into the original thing here, then I have 1 minus 3 over n times 2 to the n. So you know this from algebra. Here, -2 to the n over, I mean, you could just think about this too, I suppose. -2 to the n and 2 to the n are the same when n is even, and they're the same except this is odd, negative when n is odd. So this alternates, and there's n on the bottom. This is alternating harmonic. Alternating harmonic series, that converges, so that means we're including 1. So that's out. Now what about when I plug in 5? When I plug 5 into this, I get 5 minus 3, that's 2 to the n on the top, 2 to the n on the bottom, and n on the top. Those just cancel out. This is the harmonic series, which diverges. So it looks like we have answer choice B. And that's a lot of work to do for one multiple choice question, but that's what you have to do. And we'll pick up with number 23, hopefully last video there.